let's review what it means for resistors to be in series and parallel. So series means that two components share one node, so that the current going through one must go through the other. Parallel means that they share both ends, so that they must have the same voltage across themselves. So if I have two resistors and they're plugged one into one row and one into the other row, they must have the same voltage across them, because how could they have some other voltage? They're literally connected by 0 ohm wires. And series, the current that goes through this one must continue to flow through that wire through this one. And we get some interesting cases where I might have a resistor and another resistor and another resistor that goes back to another resistor. And maybe this is 5 volts and this is negative 5 volts. So the current comes out of 5 volts. It must split to go through these two different resistors, and then it converges to go through that final resistor to the negative 5. So what in here is series and parallel? Well, we've got this current must be equal to this current. So these guys are in series. They're not actually touching like our rule says. But we know that by the map of this circuit that this resistor and this resistor are in series. Now, these two resistors are in parallel because they're sharing ends. I could possibly put another resistor in parallel to this whole circuit. So what is this resistor in parallel to? Well, it's not in parallel to this resistor or this resistor. This resistor is parallel to this whole circuit. That's a little confusing. So you might not want to specify at that level. You might want to keep it more simple. Series and parallel is going to matter on our resistors because we don't have many resistors in our bag. We might want to make one resistor that is 500 ohms. We don't have a 500 ohm resistor in our bag. So how do we make that? Well, one way to think about it is if we have 5 volts across a 500 ohm resistor, it must have 2 milliamps flowing through it. Is that right? No. 10 milliamps flowing through it. Okay. Well, if I had a single 1K resistor with 5 volts across it, it would have 5 milliamps going through it. So if I just take that 5 volts and also connect another 1K resistor to ground, so that's in parallel, I'll have another 5 milliamps going through that 1K resistor. So the total amount of current that's leaving 5 volts then going into ground is 10 milliamps. So by putting two 1K resistors in parallel, we've essentially made a 500 ohm resistor from the point of view of the power supply. It doesn't know the difference if we've got one resistor or two resistors or a lot. So resistors in parallel, the law, and this is the confusing one, the equivalent resistance of putting resistors in parallel is equal to the sum of 1 over all of their resistance values. So that's resistors in parallel. Resistors in series, the final resistance, the equivalent resistance, is equal to the sum of all the resistors. So if I wanted to make a 2K resistor, that's the same thing as saying I have two 1K resistors.